Normalization is an extremely important step in the experiment, and if not done properly, all of the data you collect will be invalid. We're not going to cover the normalization in depth. We have a normalization guide on our website, or you can contact a DMT representative to help find information on normalization. However, there are a few key points that we want to make. First, elastic preparations like these with vessels and especially arteries can only have meaning if the size is clearly defined. This defined size will change the sensitivity to agonists, so a standardized approach must be made. Lastly, the active response is dependent on the extent of the stretch of the smooth muscle cells. Therefore, you must set your vessel to an internal circumference that will give the maximal response. After these 20 minutes have passed and your chambers have reached the experimental temperatures, you can now start the normalization. Again, today we're going to use the DMT normalization module on LabChart. So we click on the DMT and settings. Now these settings will be dependent on the type of vessel you are using. The first is eyepiece calibration, and we're going to use 1 so that we can type in the length of our vessel. Your target pressure will be dependent on your vessel type. And this IC1 to IC100 value, again, is dependent on your vessel type. And this must be done earlier to characterize the type of vessel you are using. Information on this can be found on the DMT normalization guide or through your representative. For mouse mesenterics, though, we're going to use an IC1 to IC100 value of 1. Now, typically, you will leave everything else the same, but for our video, I'm going to change the delay time from 60 to 30. So now we are ready to start the normalization, and we will be doing channels 1 and channels 2. So we saw in channel 1 that the vessel spanned the entire gap of the jaw. So we are going to set our tissue endpoints as 0 and 2. This will tell us that our tissue length is 2 millimeters. And we are using 40 micron diameter wire. And now we need to take a reading of the micrometer for channel 1. So we will take a reading. In this case, it is 2,230. And we will add that point. Now we have a 30-second delay on this one, so we can start with channel 2. Channel 2, again, span the entire gap of the jaw. So we will do 0 and 2 as our endpoints, which will tell us that our tissue length is 2 millimeters. Again, we are using 40 micron wire, so we will enter that. And now we will take a reading from channel 2's micrometer. So now we have our first point on channel 1. So now we can add our stretch and go on with the normalization. So in this instance, I'm going to add until I see, I'm going to increase the distance from the wires until I see a change in the force. So I'm slowly doing that. And now I will take a new reading. And since the second point is done, I can now go to channel 2 and do the same thing again. And now you see on channel 1, since that second point is done, we now have information on our graph. And after the next point, we will start to see our best fit line. So I'm just going to add 30 microns and let this go. And then I will do the same thing for channel 2. And after that, you will begin to see the line with the best fit curve. What we are trying to do is we are trying to just get over this target pressure line, which means that we have reached the target pressure point, which will give us our maximal responses. As you can see, though, we still have a ways to go, so I will add more to channel 1. In this case, I added 50 microns. And the same with channel 2. And you will repeat this until you reach your target pressure line. Now you don't want to go too far over that line if possible. You want to do your best to just go over it, over the top of the line. So we still have a ways to go again on channel 1, but we are getting closer. Channel 2 still has quite a ways to go. You need a minimum of 4 points in order to get an accurate reading, but typically you're going to end up with somewhere between 6 and 10 points. Again, remember, this is a best fit curve, so not all of your points are going to be right on the line. Now this one is very close, but it's still under the line, so we will do one more reading to get above that. And again, you can see in channel 2, we are close again, but not quite there. You will notice while you're still below this line, you will see an extrapolated result under the best ideal micrometer setting. Once you have passed that line, as we have now, it no longer says extrapolated result, and it now tells you the point at which you should set your micrometer. So channel 1 suggests we set it to 2558. So we will get as close as we can to that number. And channel 2 has also passed it. And in this case, its reading is set to 2076. So we will move these back to those values. And now that you have done this, you can zero your chambers, your reading for chambers 1 and 2. And this is the point at which you are ready to move on and start the wake-up protocol.